Assalamualaikum students. Today we are going to start a new chapter in chemistry, that's periodic classification of elements. Now, before starting this chapter, the first question that comes to our mind is what is classification and why do we need to classify elements, right? Why is it classification essential? So first, let us see what is classification. Grouping or sorting of elements based on their similarities and differences. It means the elements have been divided into groups in such a way that the elements in the group will have similar properties and the elements which are having different properties are placed separately. So this is classification when we group elements, when we place elements into groups and they are having similar properties there. Now, what is the need to classify elements? Why we classify elements? So, as we know that we have so many elements, almost there are 118 elements known at present, and it's very difficult to study the properties like physical properties, chemical properties, uses, application, all these things of these elements separately. It's very difficult. And for that purpose, to make that easy, to make the study of large number of elements easier, for that we need classification. Because what happens when we classify elements, the study of large number of elements is reduced. And now we have to study few group of elements. And this is the reason for the periodic classification of elements, because it makes our study easy. So in this chapter, we will describe the various attempts which have been made to classify the elements from time to time. We'll study Dobereiners Triad, which was given in 1829. Then we will study about the Newland's law of octaves, which he gave in 1864. Then we will see the attempts, laws given by Mendeleev for the classification of elements. And at last, we'll study the modern periodic law. Now, let's move to Dobereiners Triad. See, in earlier attempts, elements were classified on the basis of their properties. And all the elements having similar properties were put in one group, and that was called a family. Now, in year 1829, this German chemist Dobereiner, he observed that certain elements had similar properties, and he could put them together in groups. And those groups were called as triads. What is this triad? Triad means three. It means three elements, group of three elements. Okay. So at that time, 30 elements were known. And he classified these 30 elements. Almost 30 plus elements were known at the time of Dobereiner. And he does his classification. The base of his classification was atomic mass. He classified elements on the basis of atomic mass. Remember this point, okay? Now, according to Dobereiner's law of triad, when elements are arranged in increasing order of their atomic mass, see here, it means the elements have to be arranged in the increasing order of their atomic mass. It means the one having low atomic mass comes first, and the one having higher atomic mass comes second, comes later. Okay, so in this way elements are arranged, and they are arranged in such a way that the group of three elements is formed, means triads are formed. Triad means three. Okay, so group of three elements are called triads, and when he arranged elements, he made group of three elements, he made triads. Now what happens in that? See the further statement. Arithmetic mean of first and third element is found approximate equal to the mass of the middle element. It means that when he arranged elements in the group of triads, it means the group of three elements, the mean of the first and the third element, it means the average, mean means the average of first and third element, average atomic mass of first and third element was close to the atomic mass of the middle element, central element. You will get this point, you will get this concept clear in the example. So let me pose examples. So he made triads. Like the triad first was LINAC. What is LINAC? Lithium, sodium, and potassium. Then he made second triad, that was calcium, strontium, barium, and the third triad was chlorine, bromine, and iodine. Now see, you just remember this one triad, that is enough. Okay, so see here. First of all, the arrangement was on the basis of increasing atomic mass. It means lithium would have less atomic mass than sodium, sodium would have less atomic mass than potassium. So it is the increasing order of atomic mass. Okay. Now, see, the atomic mass of lithium is 7, sodium is 23, and potassium is 39, and it is the increasing order you can see here. Now, it is the triad because it is the group of 3 elements. Now, what he said, he told that the arithmetic mean of the first and the third element. See here, what is the mass of lithium? That's 7. And what is the mass of potassium? That's 39. So we have to find the mean of 7 and 39. It means the average, that is 7 plus 39 divided by 2. And that would be 46 by 2, and 46 by 2 is equal to 23. And see here, 23 is equal to this 23 would be equal to this atomic mass of sodium, because sodium also has the atomic mass of 23. It means the average of atomic masses of first and the third element is approximately, is nearby. Here it is equal, but in other triads it is nearby, it's close to, means there's a difference of points, so it's close to this middle element. So this was Dubin's law of triads. And one more thing, the triads he made, the elements in the triads all have the similar properties. That is why they were placed in a group, because grouping means you have to group the elements in such a way that the properties are same. So the elements in triads have similar properties. Like you can see here, lithium, sodium, and potassium, they all have similar physical and as well as chemical properties. See, they all are metals. They all react with water and form alkalis and hydrogen gas, and all of them have a valency of 1. It means they are having similar properties. Okay, and one more thing, their arithmetic first and the third element's arithmetic mean is equal to the mass of the central element, mass of the middle element. So this was Dubin's law of triads. And see, uh, same applies to triad second, same applies to triad third. Okay, so he arranged the elements present at that time. Okay, but he failed. There were some limitations to his classification. And why he failed? What was the limitations of Dubin's classification? That was, he failed to arrange all the then known elements in the form of triads. It means almost 30 plus elements were present, but he failed to arrange all the 30 plus elements in the form of these triads. Because when he arranged the elements, further elements in the form of triads, they were not having similar chemical properties. That is why he failed to arrange them in the triads. Okay. And next thing, he identified only 3 triads, which I showed you. He identified only those 3 triads from the elements known at that time. So that is why his classification of elements was not much successful.